Hey everyone, welcome to this week's Cribl Weekly Demo, Enriching Events with Data from a Threat List. So before we jump in, just wanted to take the time to introduce myself to those of you that I haven't met. I'm Desi Gavis-Hewson, and I am the Senior Solutions Marketing Manager here at Cribl. Previously, I led the National Sales Development team at a co-working company called Industrious. Prior to that, I was on the sales team at an ad sales enablement company called Media Radar, and I helped build the sales development team at Trello. So my path to Cribl is a little non-traditional for sure. And I've been in a few different industries in my career. I think ultimately, though, it's kind of a no-brainer for me to come to Cribl just because I really enjoy matching people and teams with tools that give them more flexibility and choice in their business. And ultimately, that's what our flagship product, Cribl Logstream, provides. So great to meet you. Here's what to expect on today's call. So almost every week, we'll be doing a full demo of Cribl Logstream and walking through specific use cases in the product. So first, I will do a quick introduction to observability pipelines and Logstream for those of you who may not be as familiar with us or what we do. From there, we'll move into a full demo of Logstream. So we'll talk through the specific use case for that week after that. Obviously, this week, that's going to be enriching events with data from a threat list. And then you guys will have the opportunity to ask any questions you have regarding Cribl, Logstream, or anything that you will hear or see here today. So just a quick note here for those of you that have seen Logstream before, work with it every day, or just super familiar with the tool, you'll likely find that the first half of this call is going to cover concepts you already know, right? We'll get into the specific use case at about 1:40 Eastern time. I'm based in New York, so 40 minutes from now. So feel free to go grab lunch or breakfast, I don't know where you guys are, or 5 coffees. Just come back and join us for that part of the webinar. So global data is growing at a 25% compounded annual growth rate. And I feel like everyone in the world understands this to a degree. Take being in a global pandemic, for example. Now, more than ever, organizations are making this massive transition to remote work, right? Companies are having to provide new equipment, maybe even new infrastructure in some cases, as well as use new programs and applications so that their employees can work from home, either at the same or a higher level of productivity than they were before. New programs and applications is going to mean more data sources and more data, right? So even if you think about it from a non-technical perspective, it's really easy to see data is growing astronomically. By 2025, enterprises will be managing 250% more data than they were just last year in 2020. So the amount of data is growing, but there's another problem, right? Logging systems are already at capacity. I personally hear from enterprises daily with costs in the millions when it comes to licensing, and the infrastructure required to store that growing set of data can cost as much or more than commercial licensing cost. More data also means you need more CPU dedicated to analyzing it. And for many customers, the added infrastructure costs can be in the tens of millions of dollars. On top of all that, you get inadequate data retention in some organizations. I mean, when your logging system is reaching its limits, many people believe they have no choice when it comes to dropping data that they'd ultimately like to keep around. To get the answers you need out of your environment, excuse me, you need to onboard new sources of data. There's just no way around that, really. Most companies will drop large portions of high volume sources just because it's too difficult and costly to analyze everything. You might also have, depending on your industry, right, retention policies in place to meet certain standards and regulations, but you're having to guess, right, how long can I afford to keep this wider set of data around? And you may even need to revisit that data later, especially if you're investigating a security breach or trying to understand long-term trends in your IT environment. For some use cases, they may need to keep data on hand for years, and that data needs to be ready for analysis that entire time. Lastly here, systems are optimized to handle data analysis and retention separately. So what that means is you often end up using many different tools to retain and analyze all of your machine data. And adding each one of those tools is also going to add complexity and hidden costs. So like I mentioned before, environments are getting super complex. You have your object storage, your time series databases, your data lake houses, and each of those is going to have its own agents and its own ingestion pipelines. It gets really tough to manage it all, and it forces enterprises to make some hard choices about which data to send to where. And choices usually mean trade-offs, right? You end up playing this 3-way kind of tug of war with cost, flexibility, and visibility. I mean, the more data you analyze, the longer you retain it, the more it's going to cost you. If you standardize on a single tool, it's going to limit flexibility, and dropping data to keep costs down could limit what you can learn or investigate over time. So how do you do it, right? How do you manage the trade-offs of analyzing everything you need to get insights from your machine data formatted for all the tools you use without busting your budget? Well, an observability pipeline solves all of these problems, and our product, Cribl Logstream, helps teams implement an observability pipeline without replacing any existing tooling. Cribl Logstream enables customers to choose what data they want to keep, in what format, and in which data store, all while providing the assurance, right, that you can also choose to delay any or all of those decisions with a full fidelity copy and low-cost storage. Logstream is going to give you a vendor-agnostic solution to route data to and from any tooling source or destination. So regardless of which tools you're using, Logstream can help centralize the forwarding of all your machine data, get it to the right destination, and ensure it's shaped, enriched with whatever information you need. Talk a little bit more about that in a second, and ready for analysis, or simply just on standby for when it might be needed in the future. And lastly, Cribl Logstream significantly decreases an organization's logging and monitoring costs, saving customers about 30% of infrastructure costs on average. So one question that might be popping up for you is, Desi, doesn't data streaming already exist? Yes, and the data streaming solutions that do exist are not purpose-built for polystructured data. On the other hand, an observability pipeline, of which Logstream is an essential part, right, is purpose-built to work with even the most complicated data formats. So the data you need probably exists in multiple sources with different protocols that dictate how that data is generated and collected. So you've likely got data coming in a variety of formats, right? They may not always match the formats required by the tools you use, especially if you're doing a lot of work between teams within your organization. You probably also come across streaming solutions that just can scale with your business requirements. Well, Cribl Logstream can. We've tested it at over 20 petabytes of data a day. So if you remember nothing else I've said today, remember this: Cribl Logstream is an observability pipeline to route security and machine data where it has the most value. We help slash costs, improve performance, get the right data where it's needed in the formats required. With Cribl Logstream, you can reshape, reduce, or route data so that you remain compliant and get the insights you need in the most cost-effective way possible. So next, I want you guys to see the product. My colleague, David Maislin from our solutions engineering team, has graciously recorded a full walkthrough of some of the key use cases of Logstream. Let's take a look at that now.
Hello, I'm David Maislin. I work for Cribl. I'm a principal solutions engineer, and today we're going to be giving you a brief talk of our product features, discuss the distributed deployment architecture, and cover some basic concepts and show a live demo of Cribl Logstream. So first off, what is Cribl Logstream? Well, when you have logs, metrics, and traces, and you're trying to get the data from your sources to the intended destinations, it can be quite challenging. Logs can be pretty messy, ugly, noisy, and sometimes you just want to see the signal and not all that noise. And not only that, all those events, all that extra traffic can cost a considerable amount when we're talking about your storage or your license. So Cribl Logstream will allow you to implement an observability pipeline and help you to parse, restructure, and enrich the data in flight before it lands in the data analytics store, which will get the right data where you want it in the formats that you need it. So first off, when we talk about routing data, sometimes data doesn't always land in one place. You want it to land in many places. For example, some of your data could land in Splunk, other data might land in Elastic, but all of your data, just to keep it for future reference, security investigations might need to land in S3. So we allow you to route your data to the best tool for the job, or all the tools. We allow you to translate it, reformat, enrich it into any schema that you require, because different departments have different needs for analytics. So you can put the data where it has the most value. Secondly, as I mentioned earlier, data can be quite large, noisy. There's a lot of times when people leave things like debug on without thinking about the impact that it might have on the end analytics store. So as much as 50% of that log and metrics data goes unused. There's null fields, duplicate data, fields with just no value at all. And with LogStream, you can trim that wasted data stream and analyze only what you need. We also allow you to collect data from multiple sources in pretty much any format using the tools that you already are using today. Splunk forwarders, WinBeats, Elastic, various plugins, syslog, whatever it might be. We allow you to reach out and collect the data using REST, Firehose, HTTP, TCP, and pull that data from Microsoft Office 365, for example. And once we pull that data in and it lands in the intended destinations, one of them might be something like S3. If you ever needed to replay that data, pull the data back in at any time, you can simply select a few buttons, pull that data back in, and do ad hoc data collection for later investigations. And lastly, you want to shape your data. You really want the ability to process machine data before you pay to analyze it, so that you can transform it, you can enrich it with lookups, GeoIP information, or other specific information related to your specific company, business. You can parse the data, restructure the data, so that you can focus on that signal and not the noise. Let's talk about the architecture for a distributed deployment of Cribl LogStream. As I mentioned earlier, we support all the sources that you can probably think of. We're going to be able to collect data using Splunk universal forwarders and heavy forwarders, Elastic Beats agents that have integrated load balancing. You can send data via syslog, FluentD, HTTPS, TCP, TCP-JSON. And finally, the pull sources using an API will go collect the data from the required sources like Kafka, Amazon S3, Kinesis, SQS, or Azure Event Hubs. When that data flows into Cribl LogStream, we place LogStream worker groups, a collection of worker nodes that sits closest to the egress point to save money. The idea is that if you can reduce all the noise, trim the data, drop events that simply don't matter at the source, like in the cloud, and maybe you're sending the data to another cloud provider or internally to your on-premise deployment, then it's going to save you a ton of money on your bandwidth. It's going to reduce the amount of traffic flowing into your solution like Splunk. It's going to free up additional license cost. Increase search performance. All of that is controlled through the user interface in the master node that's integrated with Git and your repos for version control, which we'll cover during the demo. Once the data is processed using LogStream routes and pipelines, it's going to land or go to the destinations of your choosing. So some of the data will go into Splunk. Other data might go into Elastic. Some data might need to go to S3 directly and never land in either store, or all of the above. The flexibility is tremendous. Let's talk about a demo. So first and foremost, when you land in Cribl LogStream, you have the ability to monitor the events in and out, the bytes in and out from your various sources. As you see here, and you can see the status of the sources that were healthy, were collecting the data, and the destinations. In this case, we can see that one of the destinations is having some challenges. Cribl logstream in the worker nodes can do persistent queuing and other behaviors, such as rejecting events or dropping events, depending upon the intended or required behavior that you choose. In this case, we could set it up such that any data that can't get to the destination can simply queue up in a persistent queue across the logstream worker nodes until the destination is back up. Maybe you're doing a maintenance on the Splunk infrastructure on the indexers. Maybe it was a network issue. Maybe it was a restart of the indexers, something like that. You won't worry about losing any of your data. If there's any challenges, all of the data will be retained with full fidelity. And again, you could also send it to multiple destinations, such as S3. Let's review some sources inside of a worker group. And again, a worker group in this case, we're going to call it logs. This could be AWS, this could be Azure, this could be on-premise, whatever you decide to call your worker group. We're going to go into this worker group. Now, the first thing you see is you are in the routes. And before we discuss what the routes are, let's talk about the sources. So here you see various sources that you can configure to receive data. So if, for example, we wanted to receive data from syslog, you select syslog and you can add your various IPs. We'll receive data on any port over UDP or TCP. We support TLS, syslog over TLS out of the box. Another source could be Splunk, whether that's the HTTP event collector or Splunk TCP. We act just like a heavy forwarding tier or an indexer in that we will receive the data. We're not going to store the data for analytics, but we're going to process the data just like Splunk. So you simply add a new source, configure the IP, the port, and you can even whitelist various IPs, configure the line breaking, event breaking, add additional fields, and do any additional pre-processing before the data enters the routes and the pipelines. Let's take a look at the routes. So what you see here on the left, from the top to the bottom, is as data comes in, we're going to match data against a specific filter. This might look somewhat familiar to you. This is JavaScript expressions, which is a very universal language, so that we basically have said, if data comes in for Palo Alto network traffic, then process it with a pipeline. A pipeline is a set of functions that is applied to a route. Finally, output the data to one or more destinations of your choosing. And at the bottom, you see final. Final means you're done with this data, this specific type of data. Do not go to any of the routes below that you see here. The next route we see is the archival route. It says true. So all data that hits this specific route is going to pass through. No filtering, no functions are being applied, and land directly in S3. This isn't final, so this means that data will continue down the routes for additional processing to land in additional destinations. If at any time you make a decision, because in this scenario, we said that the Palo Alto traffic is final, it's never going to land in S3, and you wanted to make sure that all data landed within S3, you can just drag the route and change the order of processing. And now what we are saying is all data that passes in through these routes is going to go and land in S3, including the Palo Alto data. Once you make a change, you just simply save the change. And as you see here, you can commit the change because we're integrated with Git and your local repos as well. And I'll just say changed the order of the routes to include pan data. Once I commit that change, I can deploy those changes. And once I do that, the workers are going to be checking in every 10 seconds. And in this case, the logs worker group is going to check into the master, notice that there's been a change to the routes, pull down the changes, then they're going to process the data according to those changes. Once the data is done being processed, it's going to now land in S3. When it receives the change, the config version here will then turn green. That happens about, I don't know, somewhere between every 10 to 30 seconds, just like you see right here. It is now green. Let's go back to those routes again. And now we're going to take a look at some of the various pipelines that we've applied to this data. In this case, we're going to look at trim big JSON data. This is the filter that it's going to match on. We're going to enter the pipeline from the route. And here we see we are now in pipelines. We have a comment. Comments allow you to document everything that's happening within a route or a pipeline. And in this case, we're going to capture some data right now live from the various workers in the log worker group. When we capture data, you can see that the filter expression carried over when we enter the pipeline from the route. And it's going to allow me to capture the data from the various worker nodes, adjusting the time frame that I capture, as well as adjusting how many events I want to capture and where I capture those events. As they enter the system at step 1 before processing, as they enter the various routes and processing pipelines, and as they exit for various post-processing, and finally, as you see here, on the way to the destination. So let's just capture the data before it gets processed. We'll hit start. Now we see the events are flowing in, and they're captured into a sandbox. This is a temporary staging place where you can create new pipelines with various functions and test out the behaviors before you deploy it to the various worker groups. If I don't do anything and I just stop my capture now, it's going to expire this captured sample after whatever time frame you set. If I were to rename this, something like that, now this will no longer expire until I choose to delete it. It's helpful for keeping a template of the various events that you're processing through Cribl Logstream. Let's save this as a sample file. Once I hit save, we now see here on the right that we have data. These are very large JSON events. We can recognize the format of structured data so that if I select expand, I can now see the JSON object. And the one thing to note is what we talked about in the comment earlier, is we need to remove multi-header and null fields from the raw event. And we're going to apply a function called parser to the data. If we look at the data on the right, as it comes in, we see body, we see headers with 20 items, and headers has the various accept and CloudFront and other bits of data, but there's also a redundant field here called multi-value headers, which has the same values that you saw in the headers field up above. We also noticed that there's some null data here. Why would you want to pay for data that has no value? Let's look at the parser function. We're basically saying for the source type of Lambda, this function is going to be processing the event. We are going to remove the multi-value headers and the null fields and rewrite raw using a reserialize operation. We could just as easily extracted fields as the extracted fields like you would see within a data model inside Splunk by changing the operation mode. And in this case, since I know the data is JSON and I'm applying this function to the source field of raw, here's what I'm going to do. Remove multi-value header field. And this fields filter expression basically says only keep events that are not null. Value is not equal to null using the expression here, the JavaScript expression, which matches on the value and the type as well, ASCII or numeric. Let's take a look at what would happen if I send the data on to the intended destination. Well, first, when I expand the object, you'll notice that multi-value headers is gone. Null values have also been removed, but yet the event has been reserialized in the proper structure, something that would be pretty much impossible to do using things like sed command or regex to manipulate the structured event. If I wanted to remove additional fields like request context, just type it directly into the fields to remove. Hit enter and hit save. Now again, this is not being applied to the worker groups until I commit and deploy the changes. And if I made a mistake, I can roll back to prior releases of the changes with the click of a button. Once I added this new field, let's take a look at the savings. So now, almost 65% of the event size is gone. It's been reduced, but we've not lost any of the value of the data. The full fidelity still exists, not only because we've removed redundant fields and no value fields like null, but also because all of the data is also landing in S3 in case you perhaps needed to see the original event before you reduce the event. If in the future, once you deploy this change to your event, your manager says, you know what, we actually need this field, so please add it back into the data, you select it, remove it, hit save, and what you'll notice is now request context is now included in the event, sending on to your destination like Splunk. If I take a look at the changes now, it still shows that we're removing about 45% of the event, a tremendous reduction in license. Because you've also removed redundant data and null value fields, it means less data is going to land on your indexing tier, and that means your searches are going to be much faster. Further, because all of the data is landing in S3, you don't have to retain the data for as long, because it's not very often that you're asked to run a search from 3 months ago and display the results. We're looking at the here and the now. Other reasons are because the data is in S3 untouched, you might want to replay the data in the future. So sometimes organizations have set up clustering and replication, which can take your data that's been indexed and make 2 to 3 copies of that data across your indexing tier. That can cause additional performance issues. Well, now that you have the data in multiple places and can replay the data at any time, you could make a decision to reduce the amount of retention, saving infrastructure costs and storage costs, because you have less data in the environment, because you're no longer needing to cluster or replicate the data. That's going to increase your overall performance. And finally, the reduced events That's going to save your organization a tremendous amount of license that now has been opened up for other data use cases, which would allow you to pull in additional data. So that's a review of a single function in Cribl logstream. We see trim big JSON. Let's review something a little more complex and more powerful. We'll take a look at Palo Alto firewall traffic. So I've entered the Palo Alto traffic from the route, and I'm in the GeoIP Enrich pipeline that we see right here. This pipeline is a collection of many functions that exist within Logstream. These functions include things like the ability to aggregate data as metrics, perhaps, again, adding comments, dropping data, sampling and dynamic sampling, suppression, keep one out of every 100 events that are from trusted zones, for example. Regular expression extraction, I'm sure many of you are used to that. Updating your props and your transforms can be difficult, and sometimes you can make mistakes. We allow you to parse data out of the box, and all of this is done through the user interface. There's no need anymore to update things within config files and have to deploy them out to the indexing tier and wait for indexer rolling restarts, for example. Let's review this pipeline. So again, we're commenting. What I'm saying when I enter this pipeline is if somebody accidentally said, send the data to this pipeline and it's not matching the source type of pan traffic, you're final, you're done. Don't process that data, leave this route because we're not going to accept that data that doesn't have that source type. The next function is parser. And as you see here, it says on all data that was allowed to enter this pipeline, its filter is true. So all data that comes into this pipeline, I'm going to extract all the events from that, all of the field names from that event. Let's take a look. Here is data as it comes in. It's in the syslog protocol. We can see that here because of the facility and the log level exists right here. We can expand that. We see the common delimited event. This is what the data looks like as it leaves this pipeline. All of the fields have been extracted as well as enriched, which we'll cover in a moment. This is, in a sense, a pre-built data model. These extracted fields will land in Splunk, and you will be able to search for them using tstats. It's basically building your data model before you have to do it inside of Splunk, which can affect the performance of your indexing tier. You no longer have to run data model acceleration every 5 to 15 minutes. And again, it's a tremendous improvement in the performance in your environment. The fields here that you see within this parser function, I just simply copy these and pasted them from Palo Alto's documentation on what represents a Palo Alto traffic event. If at any time you didn't want to pull specific fields, you can remove them. You can decide which fields to keep, which overrides which fields are removed. And again, like you saw earlier, you could decide to not index any null value or events that just simply don't matter, like placeholder events, for example, future use. Let's minimize this. And one of the things that you'll notice is I created a group so that way I can easily understand what is happening within my pipeline. The first group is extraction and reduction, and I have other groups below here. In the extraction and reduction, I also have a drop function where if a log subtype equals start, the event will just simply get dropped. It could be if you have debug logs coming and you choose to drop them because you don't want to fill up your indexing tier with debug at any given time because nobody told you that they were going to turn it on, and perhaps they accidentally left on debug, and it's going to have a dramatic impact on your indexing tier. Other things that you could choose to do would be like sampling. If I'm getting bytes in is equal to 0, maybe keep 1 out of every 5 events. That's what we see here. If I'm getting data in from the firewall from trusted zones, internal networks, maybe keep only 1 out of every 10 events, which would again be about a 90% reduction of your traffic that normally gets indexed but never searched. Nobody looks for it. And this is on or off. I could turn this on with the simple toggle of the switch right here. Let's move into enrichment. In this case, we've again commented, we're going to do GeoIP lookups against MaxMind for the source IP and the dest IP. And we are going to output a result field, source underscore GeoIP and dest underscore GeoIP. And we see that right over here on the right. We see the city, the continent, the country, the locations, the postal code, subdivisions, and things like that. That was done on an event-by-event basis, pulling in the data, enriching it at search time, because IP blocks change. And in 6 months from now, in a product like Splunk, if you were to do a search lookup against an external IP, the location, according to MaxMind, could change. And so it might be best for you to add the enriched information at index time for the purposes of a security investigation. Maybe a year from now, you needed to replay that data from S3. Having the comfort knowing that this information was enriched before it went to S3 and landed with that data means that your security team will have accurate information when they recover that data. We, of course, support other things like lookup tables, reverse DNS. We'll take an IP and match it to the DNS host names, as well as maybe internal CIDR notation, where I'm saying if the IP address comes in and it's internal, do a lookup against this lookup table and return the CIDR output. Other things that we do would be to look at compromised tables. This is a value expression which says look up the IP address information, and let's do a pop out here. Look up the IP address information against the source IP or the destination IP and simply match on that. And if it's true, then return the result or false, as you see here, all done within our UI. Additional routes and pipelines might be used for the purpose of sensitive data, and in this case, masking data, like from a business event we see right here. So for business events, maybe you're looking at this data sample right here, and you say, what is the effect of this function to look for social security numbers, credit cards with LUN algorithms, things like that? We have built-in expression matching that you see right here. We said, go look for a social security number pattern and mask it using an MD5 hash. This is what it looks like as the event comes in, and this is the masked event as the event leaves the system to the intended destination. We do the same for regular expression. If you're working within the solution and maybe you need to do a regular expression extraction on the fly without having to go to external sites where you might copy sensitive data and paste it to a site where you're not supposed to do that, you can create your expressions directly inside Logstream and create the match right here inside our user interface. And when you're done with the capture that you might need to use as a field name. You simply save it. And then what you will have after you save it is a new field name right there. That's the power of Cribl Logstream. Now, I've shown a lot of various capabilities of Logstream, how data comes into routes, how data is processed within a pipeline, and as I've talked about, how data might land in multiple destinations, including S3. And as we know, we don't retain data in the data analytics store for very long because the storage can be enormous and expensive. So by reducing retention, maybe from 12 months to 30 days, because that's typically what a lot of organizations might do when they use Logstream, the infrastructure cost is going to go down dramatically. But Logstream, if you ever had your security team call you and say, hey, we need to recover data from all the data that happened a week ago, a month ago, a year ago, inside of Cribl Logstream, first off, I'm going to replay the data using a collector from AWS S3 storage. It could be MinIO backed storage, where the data is sitting locally in your environment. I can preview the data before I re-index the data and pull it back into the system. I select the date if I wanted to maybe go back a week. I can change the filter because maybe you included tokens when you wrote the data out to the destination, like the source IP, the dest IP, the username, the department, the source type, the host. You can update your filter to match any specific recovery match that you would need to pull back in without having to pull back in all of the buckets that traditionally you might have to run a script on a single host. When we do the recovery using Cribl Logstream, all of the worker nodes are tasked to do the recovery where it load balances the recovery of the data. Here I'm choosing to preview the data before I pull it in against an absolute time range. For the next 60 seconds, I'm going to look for 100 events. And this is a live capture directly from AWS. This is not a demo. And we see the events. Just like you saw earlier when I captured events into the sandbox, I can save this as a sample file. And once I've saved that sample, I can close out this sample, go back to my pipelines, review that sample right here, create additional routes and pipelines against this sample, and recover the data to perhaps a different destination. Maybe I want to recover the data to a third-party provider. Maybe I've moved to a managed service provider and I want to transfer all data to them. Maybe I want to recover this data that used to exist within Splunk, and now I want to recover it into Elastic. All of the things are possible because you have the ability to, again, collect from any number of sources and land the data into any intended destination through the routes and the pipeline pairs. And that is the demo of Cribl Logstream. I hope you found value in today's presentation. Thank you.
Awesome. So you just saw a few general use cases of Cribl Logstream. Hopefully that's got some gears turning for you around how Logstream can help you optimize your data. Now let's get a little more specific though. So I mentioned we'd be walking through enriching events with data from a threat list. With Cribl Logstream, you can easily cross-reference events as they come in with known threat lists. From there, you can enrich those events. So one example of possible enrichment might be a threat status, right? So once that event comes in, it gets checked against your list of known threats, and assuming it's on that list, we can then add something to that event saying essentially, this is a known threat. Maybe that even sends an alert to your security team, right? So doing enrichment like this streamlines threat detection and speeds up your ability to then respond to that threat. So my colleague, Kyle McCreary from our solutions engineering team walks through how it's done in this video.
Hello, today I'll be demoing how to use a Logstream REST collector to pull a thread intel feed from GrayNoise's query language API to create and update entries in Redis. This information can then be used to enrich events flowing through Logstream with a threat feed's categorization value for an IP address found in the event. So the first thing that we have to do is create an event breaker for the data coming from the GrayNoise API. So let's take a look at that format of the data. And we see it's a JSON event with a data array with the IPs and the categories, as well as a field for the next page token. So let's go ahead and go create the event breaker by going to knowledge, event breaker rules, and add a new one. We'll call it GrayNoise, and we'll add a rule called data. The event breaker type, in this case, is a JSON array, and we want the fields extracted from this JSON, so we'll click yes. And finally, we'll set the max bytes to a large enough number to make sure we get all the data in. We'll go ahead and save that rule. And now we have the event breaker for the data coming in from the GrayNoise API. The next step is creating a pipeline to update our Redis instance with that data. So let's go ahead and create a pipeline by going to Pipelines, Add Pipeline. And we're going to call this pipeline Process GrayNoise Export. So like I said, this function will, or this pipeline will have a function that updates our Redis instance. And so to do that, we'll use the Redis function. And the Redis function, we will set the key and the args, and the key will be the IP that we saw. So we're going to put gn underscore IP underscore the IP from the data. And for args, we'll put classification. Then finally, we'll add in my Redis database URL and click Save. Now we have a pipeline that will update our Redis instance with the data coming in from the API. The next step is to set up the collector for the API to bring in that data and associate it with this pipeline. So let's go to the collectors, and I've started to create a GrayNoise REST collector. I have my collect URL, and we're going to be getting from this and we can pass some parameters here, the query, the scroll, so that we can have the next page token and the size, as well as some collect headers of accept and key. Next, we'll be selecting the response body attribute for the pagination scheme, and we will put scroll as the response attribute. And finally, we'll set the max pages to 0 to bring in all of the pages. We want to make sure that our event breaker is the GrayNoise event breaker we just created. And finally, we will associate this with the pipeline that we just created, the process GrayNoise export. And we're just going to be sending the results to dev null because the magic happens inside of this pipeline. So we'll go ahead and click Save. And now our collector, our REST collector, is set up and ready to run so that we can get our data and update our Redis instance. So let's go ahead and select Run. We'll do a full run. And if we look, we can see the job pulling data, and in a few seconds, we'll start to see data flowing through. Now, once that's finished, we'll be able to look at our Redis instance here, and we can see by doing a head that we are starting to get entries into our Redis instance. So now that we have our collector set up, the event breaker is correct, and we have a pipeline that's updating our Redis instance, we can now set up a pipeline to enrich data coming through Logstream. So let's go ahead and go to pipelines, add a pipeline, and we'll call it Enrich Gray Noise. And for this pipeline, we're going to be using the same Redis function, but in this case, we're going to be using it to enrich our events. So let's put in a Redis function. And in this case, the result field will be threat class. The command will be get, because we're getting it from our Redis instance. And the key will be the IP that we had put in previously. And we'll leave args blank. And we'll go ahead and add in my local Redis instance here and click save. And if I pull up a sample set of data over here on the right, we could see that this data is getting enriched by using this Redis function and is adding a new field called threat class. And for the IPs that it found, it will either put in its classification of malicious, or if it is unknown, it will be unknown. And for IPs that it did not find any data, it will return null. We can fix this by putting in an eval function that will take the threat class, and if there is any information in it, we'll take that, and if it's null, we'll put none. Go ahead and click save. And now you can see for my ones that were null, they are now none, and I have my data enriched by the data from my Redis instance that I updated from the Gray Noise API. Thank you.
I'm going to do this right. Okay. Now I'm more than happy to take any questions that you guys may have about Cribl, Logstream, or anything you've seen or heard here today. If you have any questions that came up for you during this hour, please use the Q&A feature here in Zoom to submit those at this time. I don't see any questions coming through on my end, which is great. It means the walkthrough was super clear. So that's that. After I get the recording back from this call, I will share that with you guys via email. It'll also be available on our website at cribl.io/resources if you'd like to rewatch it. On next week's demo, we'll be walking through redacting personally identifiable information, or PII, from data. So that could be, personal health information. It could be credit card numbers, social security numbers, any sensitive data like that you would want to either obfuscate or encrypt as you're working with that data across teams in your organization. So I will see you there next Wednesday, same time, same place.